So at the very beginning, I have a function called menu, and it's just outputting the menu. It's a bunch of print statements, super easy, super fun. Next, we have getRoman, which is getting Roman inputs from the user. So first, it's going to print out to enter a Roman numeral. And if they're stubborn and they don't put in a valid Roman numeral, it's going to keep prompting them to try again. And it calls the isValidRoman function right there, which is going to be down here. I'll explain that in a bit. And then once they have a good Roman numeral, it's going to make that all uppercase, and then it's going to return that back. Next is isValidRoman. It's a big function here. So at the beginning I have it set as true, but all these are tests to see if it's false. So if it's false, it's going to change it to false later. And it's going to make sure everything is uppercase because I'm working in uppercase here. And I have length because I use the length of their input a lot. And I also have relative value. So here I put all the Roman numerals that we're using in this project in a list from smallest to biggest, and that will be a helpful tool for later. So the most important check, or the easiest check, is seeing if they're all actually valid Roman numerals. So I, V, X, L, C. And if it's not that, then everything is going to be automatically false. And in each numeral, there can only be one V, as well as only one L max. And this is the mini function for that, mini test. So it's going to go through, count how many V's there are, and if it's more than one, it's false. Same thing over here. More than one L, it's going to be false. Alright, so a slightly more complex test is you can't have more than 3 of the same letters consecutively. I is good, but I, 4 of them is not good. It should be IV instead of 4 individual I's. So this is the test for that. It's going to take substrings of 3 at a time, and it's going to iterate through and compare them. So within the substring, oh wait, no, it's going to be groups of 4, sorry. So in each substring, if there's 4 of them that are the same, then everything's going to be wrong, because you can't have 4 individual I's. And same thing with X's. You can't have 4 individual X's, it should be XL. That's what this is about. Alright, so we have some illegal pairings, such as IL, VL, VX, VC, IC, and LC. You just can't have those. So I put those into a list, and if they ever show up in the Roman numeral that they put in, it's automatically false. That's what this is. It takes substrings of 2 at a time, so essentially pairs. It's going to look at each individual pair in the Roman input, and if they match up with anything that's in this list, it's going to return false. And another rule that we have in Roman numerals is there can only be one smaller value that precedes a larger value. So you can't have IIX, you can only have IX, and you cannot have IXL because that's 2 smaller values before the bigger value of L. So that's what this is about. So it skips 1, so it starts at index 1, and then it's going to look at the one behind it, and it's using this list that was at the top here, the relative values. And if you have IV, you can't have 2 of the smaller ones before a bigger one. And this is bigger, so you can't have multiple of these guys before one of these big C's. Alright, so that's what this is about. And then this is an incorrect subtraction rule. So if they used a subtraction rule, they can't add another value to that. So this would be 4, but then they tried adding an I, which would be bad. And these are some examples of that. So this would check for that. So it starts at the first, well, it goes throughout the whole Roman input, but it's going to find one, and then if this value is less than the value next to it, using the relative value array, that means it can't repeat right after it. It can't sandwich the one in the middle. And if it does, it's going to return false. Alright, that's what that's about. And at the end of this whole big function is going to return what valid is. Alright. Converting Roman to Arabic. So I have Arabic as an int. Is this going to be 0? And the Roman input's going to just go to uppercase. So this is really basic addition here. If the computer sees an I, it's going to add a 1 automatically to Arabic. Same thing with a V and 5, so whatever the value is, it's just going to add it. It's going to add everything up it sees. But of course, because of the subtraction rule, there has to be adjustments. So this is an adjustment when it sees IV. So the computer, when it sees IV, is going to think it's 6, but in reality it's only 4. And so that's just an adjustment of subtraction 2. That's it. And that's a pattern that works. Same thing for IX. The computer thinks it's 11 because it's I, which is 1, X is 10, 1 plus 10 is 11, but it's really only adding 9, so just subtract 2 and you have 9. XL, same thing. It thinks it's 60, it's actually 40, so subtract 20. If it sees an XC, it's going to think that it's 110, but in reality it's only 90, so again, subtract 20 and you get 90. And then return the Arabic equivalent of the Roman input. Alright, Arabic to Roman. This one's a little more complex. So I have this empty list of Romans that's going to spit out at the end. So, before it really gets started, if the value is negative, then it's going to put in a negative sign in front and going to multiply the input by -1. So we're working with positive values. And so basically I have these digits, hundreds digits, tens, and ones place, and then it's gonna convert like these going by hundreds and tens to ones. It's gonna make those each Roman numeral equivalents, and it's gonna put those into the array and then spit it back out. So for the hundreds place, if it's greater than 100, for each 100 it's just going to print out a C, right? And if there's no hundreds, then there's no C's. So this is really easy. For the tens place, if it was greater than 90, then that's going to be an XC, which is a special subtraction case, which is why it has its own little place here. It's going to add an XC to whatever was in the list. And if it is greater than 50, then it's going to be an L. It's going to add an L. And for every other 10, it's going to add another X. So if it's like 80, that's 1 L and then 3 X's. That's what that's about. 40, that's just a very specific case, like the 90 XL. And then anything below that, as long as there's still a 10, so let's say there's 20, then that means there's 2 tens, so it's going to print out 2 X's, which is that. For the ones place, same thing pretty much as the tens. Print out a 1, a I every time there's a 1, IV for 4, and then a v, and then additional i's as needed until 9, and if it's 9, then ix. And then here it's just joining everything together in the list, and it's going to return that back. So these are the arithmetic functions. So in the arguments, we have Roman to Arabic of the Roman input, and then Roman to Arabic. So inside of this whole argument is an Arabic total. And so putting that from Arabic to Roman is going to Romanize all of that, and it's going to spit that out. So putting in Romans, getting out Romans. Subtraction, same thing. It's just same thing, subtraction. Same thing, multiplication, same thing, division. Easy. Alright, the main function. So it says hello, welcome. Very fun. Then it's going to print the menu, and then the selection, which is whatever they input in, and uppercase that selection because I worked in uppercase. So if they are stubborn and they don't put in a proper input, then it's going to prompt them again and all that. Alright, so this is the main beef of the program. As long as it's not Q, right, that means they made a proper selection, and we're going to get started. So it's going to ask for the first value, which is Roman 1, and then Roman 2. And I also declared the Arabic equivalents of those, which will be helpful. So if they clicked A, that means they want addition. So this is the addition of the program. So just printing out the Roman equation here. So Roman equals function call of Roman 1 and 2. So it's the total, and here's the Arabic equivalent of that. Same thing for subtraction and multiplication. Division is a little bit different because if there is a remainder, which is this, it's going to print out what the quotient is as well as what the remainder is. And then after all that's done, it's going to prompt them again for another selection. And this is another validation if their selection is valid. And if they press Q, that means we hop out of this whole loop and we say goodbye. Alright, here's the demo portion. So it says, welcome, and let's get started. Here's the menu. Let's say we want to do addition. So let's do a whole bunch of inputs that would make this not work first. So we have LC. Yep. VX doesn't work. VM, M isn't part of our program here today. IL, that's illegal. IC, that's illegal. AB, neither of those letters are part of the Roman numerals. Alright, let's do C, X, 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 X. So that's 4 X's. Should not work. And it doesn't work. X, I, and that also doesn't work. X, C, X. So that's the sandwich that doesn't work. Yep. And A, B, and C. Nope, does not work. Alright, let's get serious. What's something that does work? CLX, VII. 167, 167. XL should be 40, and it's 40. And down here, we have CCVII, which is 207. So things are going smoothly so far. Let's move on. A, addition. CCCXIX, which is 319, yes. And IV, which is 4. And adding those together is 323, which is CCCXXIII, which is what we got there. Alright, let's do another addition. Simple 3 and X. That should be 13, XIII. Perfect. Alright, let's do subtraction now. Let's have CLXXIX. That should be 179. Minus CXLIX, which is 149, which equals 30, which is triple X right there. Perfect. Alright, let's do another one. It's going to end up with a negative number now. We have XL 40 and CCC XI. Now that should be negative 271, which is what we have right here. So 2 C's, 1 L, 2 X's, 1 I, 271, negative 271. Alright, let's do multiplication now. Multiplication. XXXIII, 33, times 9, which is IX, which should be 297. Perfect, we got that right there. And let's do a division. CCC XXXIII, 333, divided by 11xi, which is this big float. So this is a problem where we have a remainder, and so the quotient is 30, and the remainder is 3. Let's do another division problem. The first one will be CCXXVI, 226, and the second one will be CXIII. And we got just 2, and there's no remainder, so it does not output the remainder. And if I press Q, it says goodbye. So goodbye.